Hello and welcome to this video lesson on patterns and algebra, where we will explore how to find the function rule from a table of values. Our learning goals for this lesson are: I can describe the rule that determines the values of the dependent variable from values of the independent variable. I can investigate strategies for determining a value of the independent variable of a function given the corresponding value of the dependent variable, and I can solve problems involving a function. Our language goals are: I can talk about functions using words like input, output machine, and pattern rule. Hello and welcome to this video lesson on patterns and relations, where we will explore patterns from tables. Our learning goal for this lesson is: I can explore the relationship between the two columns in a table of values. And our language goal is: I can talk about patterns using words like table of values, column, relationship, and pattern. We can use pictures to help us show the relationship between the input and output columns in a table of values. So for example, in this table, the input increases by 1 each time, and the output increases by 3 each time. Now let's explore what that might look like if we were to draw a picture to show that relationship. We could draw a pattern of triangles, for example, on triangular dot paper, or we could use a tool like Polypad. It might look something like this. Let's explore this picture along with the table of values to see how it represents that relationship between the input and the output. Here we go. So when we look closely at this drawing and the input-output table, we can see that the figure number 1, 2, 3, 4, 5 increases by 1 each time, and that represents the values in our input table: 1, 2, 3, 4, and 5. So our figure number is the input. And the number of triangles in each figure follows the same pattern as the output. So in figure 1, we have 1 triangle. That matches our output column. In figure 2, we have 1, 2, 3, 4 triangles, and that matches our output for figure 2. Figure 3, looking at the input-output table, should have 7 triangles, and if we count them here, 1, 2, 3, 4, 5, 6, 7, we see that that relationship holds true there. And the same goes for figure 4 with 10 triangles and figure 5 with 13 triangles. So this is just one way that we can describe the pattern that represents the relationship between the input and output using a picture. We can use a pattern rule to describe the relationship between the two columns in a table of values. In this case, the table shows the input and output for this 2-operation machine. Now that means that our input-output machine does 2 operations. Now, just remember, operations means either addition, subtraction, multiplication, or division. When we find the pattern rule that describes the relationship between the input and output columns, it tells us the numbers and operations that go in the corresponding input-output machine. And if that all sounds confusing, follow along with me as we go through it step by step. When there are 2 operations, it's a bit more complicated to find the pattern rule that describes the relationship between the input column and the output column. So here's a good way to figure it out when that happens. We're going to start by looking at the pattern rule for the output. In this case, that pattern rule is start at 1, add 4 each time. Start at 1, add 4 each time. Now, when the output increases by 4, see my big exclamation mark there? That is a clue about what to do. In this case, the output increases by 4 each time, where the input only increases by 1. So that tells us that we have to use multiplication and that each input must be multiplied by 4. Let's look at that in a bit more detail now. Okay, so I just said the output increases by 4, so each input must be multiplied by 4. And if you're wondering, how the heck does she know that? Bear with me, we're going to go through it step by step. Now we're going to take a look at the input. Okay, let's look at the second input on the table, number 2. Okay, so the next step is to multiply 2 by 4, because as I said, when our output increases by 4 each time, that's a clue that we multiply by 4. Okay, so 2 times 4 makes 8. Yay! Except the output is 5. So you may be thinking, uh-oh, I got it wrong. But pause for a second. It actually makes sense because we know there's a second operation here. And it's going to be something that changes the number from 8 to 5, or whatever happens to be in the output column. So I hope you see how that makes sense, because we have a second step, so we know the output is going to change after the second step. Okay, so this works really well when you know you have 2 operations in your input-output machine, 2 steps. So in other words, we're not wrong, but what we did was we just found the number that goes in the middle here. Okay, so we started with the input of 2, we multiplied it by 4, and we're halfway through. We're in the middle. We still need to do our second step, which is going to give us the output of 5. So let's figure out what the second operation is. All right, now we ask ourselves, how can I get the output to 5? Well, I have 8. In order to get to 5, I need to subtract 3. So -3 is going to go into the second part of the machine, because 8 minus 3 equals 5. So in my first step, I multiplied by my input by 2. It gave me that middle number, and now I have to figure out what is my second step, my second operation that will give me the right output. The output I'm looking for, an input of 2, is 5. So I have to say, what's my middle number? What operation do I do to it to get to the desired output? In this case, -3. So that's what we're going to pop into the input-output machine. So now we know this input-output machine multiplies each input by 4 and then subtracts 3. So what is the pattern rule that relates the input to the output? Multiply the input by 4, then subtract 3. The pattern rule that relates the input to the output is what your input-output machine does. Okay, so we have our pattern rule that relates the input to the output. Multiply the input by 4, then subtract 3. Now we have to check all the inputs to make sure we found the correct pattern rule, the correct numbers and operations to put in that input-output machine. And then we can use that rule to predict the output for any input. So let's check our inputs. 1 times 4 minus 3 equals 1. That's correct, because 1 times 4 is 4. 4 minus 3 is 1. So our input and our output match what they're supposed to be. If our input is 2, we have to do 2 times 4, which makes 8. 8 minus 3 gives us 5, and our output is 5. We just went through this one, so we know it's correct. Now, if our input is 3, we do the same thing. We multiply the input by 4. That gives us 12. Then we subtract 3. 12 minus 3 equals 9. And our output is 9. So it looks like we're on the right track, but we're going to check all the inputs just to be sure. Next up, 4 times 4, that makes 16. Subtract 3 from 16, and we get 13. That matches our output. One last input to check here. 5 times 4 makes 20. 20 subtract 3 equals 17. So all of our inputs match. Now, we can use this to predict the output for any input. So I could say to you, what if the input was, say, 8? What will the output be? So for an input of 8, the output should be 8 times 4 minus 3 equals 29. And we can check that this is right by extending the table. If we simply add 1 to each input, because our pattern rule for the input was start at 1, add 1 each time until we get to 8. Then we add 4 to each output because our pattern rule for the output was start at 1, add 4 each time. Sorry about that sneak preview of the next screen. So then we see that 8, if the input is 8, the output is 29. So it works, and we know we're right. We used the rule, multiply the input by 4, then subtract 3 to predict the output for 8. And we also extended the table and proved that that was right. Now it's your turn. Priya made an input-output machine that uses 2 operations. Here's the table for Priya's machine. First, determine the function rule. That's the instructions for the machine. So what goes in where those 2 question marks are. Okay. First, determine the function rule for the machine. Then predict what the output will be if the input number is 10. Good luck.